Hey guys, I'm Aditya Vardhan.
I'm Tushar.
And my name is Kumail. Today we are going to talk about the OSI model.
Communication, a very important segment in today's world. Placing an order at Starbucks, making new friends, or straight up yelling violently at your friends for a pass during a game of FIFA.
Pass, Aditya! Aditya, pass!
I got this, don't worry.
Pass, dude, I'm in the goal. Pass, bro.
Come on, come on, come on! Shit! All involve an exchange of words for us humans. Communication across computers, on the other hand, involves an exchange too, but in this case, that of data.
This communication over a network is made to be more easily carried out with the reference model, called the OSI model, made by the ISO. Ha, it's spelled backwards. Anyway, the ISO, which stands for the International Organization of Standardization, makes sure that the consumer can have confidence that their products are safe, reliable, and of good quality.
For example, toy safety and road safety. ISO creates documents that provide requirements, specifications, guidelines, or characteristics that can be used consistently to ensure that materials, products, processes, and services are fit for their purpose, bringing real and measurable benefits to almost every sector imaginable. Standards underpin the technology that we rely on and ensure the quality that we expect.
Standards in the ISO are created by a lot of people working together. A draft is developed and a voting procedure is carried out to come to a consensus. The draft passes to become a standard if enough votes for the draft have been placed.
Getting back to our main topic, OSI or Open Systems Interconnection is a conceptual framework for how applications can communicate over a network. OSI models are used as a guide for vendors and developers so the tools they use will interoperate, that is, work with other devices over a network. It is rarely implemented, although, as the developers seem to laze and avoid putting things in detailed, layered format for simplicity.
The main concept of OSI is that the process of communication between two endpoints in a network can be divided into 7 distinct groups of related functions. Each communicating user or program is at a computer that can provide those 7 layers of function. So in a given message between users, there will be a flow of data down through the layers in the source computer, across the network, and then up through the layers in the receiving computers.
The 7 layers of function are provided by the combination of applications, operating systems, network cards, device drivers, and networking hardware that enable a network to put a signal on a network cable or out over Wi-Fi or other wireless protocols.
They are the 7 layers, seemingly hard to remember at first, but in fact, they are even more complicated for me to explain. All the best to me. Basically, these layers all have a task to provide service to the layer above them. Services therefore work within one machine but work through different layers. These layers also have a bunch of protocols which are guidelines to communicate with the corresponding layer of the other devices in the network. They work within one layer of several machines. They are the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer.
Layer 7, the application layer. This is the layer at which communication partners are identified, network capacity is checked, and that creates something to send or opens the object which is received. This layer is not the application itself. It is a set of services an application should be able to make use of directly, although some applications may perform application layer functions.
Layer 6, the presentation layer. This layer is usually part of an operating system and converts incoming and outgoing data from one presentation format to another. For example, from clear text to encrypted text, and one end and back to clear text and the other.
Layer 5, the session layer. This allows end users to create sessions. If more than a single data stream is created, like in a video call, audio and video being treated as separate streams, the session layer binds them together. On the internet, the TCP, Transmission Control Protocol, a standard that defines how to establish and maintain a network conversation via which application programs can exchange data, and the UDP, User Datagram Protocol, an alternative communications protocol to TCP.
Layer 4, the transport layer. This layer manages packetization of data, then the delivery of the packets, including checking for errors in the data once it arrives, and the packets are then passed on to the upper layers. These tasks are carried out by the UDP and the TCP too. Layer 3, the network layer. This layer handles the addressing and routing of the data. That is, sending it in the right direction, to the right destination, on outgoing transmissions and receiving incoming transmissions at the packet level. The network layer for the internet is IP, the well-known internet protocol, which is a 32-bit number that identifies each sender or receiver of information that is sent in packets across the internet.
Layer 2, the data link layer. This layer sets up links across the physical network, breaking packets into units called frames and trying to error check. It has two sublayers.
The media access control layer, which is concerned with sharing the physical connection to network among several computers, and the logical link control layer, which is concerned with managing traffic, flow and error control over the physical medium. Ethernet is the main data link layer in use. Layer 1, the physical layer. This layer conveys the bit stream through the network and electrical, optical or radio level. It provides the hardware means of sending and receiving data on a carrier network.
To revise with, application layer is where the users interact with applications to provide data. Presentation layer is concerned with the format of the data that is exchanged between the end systems. The session layer involves the users on different machines to create sessions between them. The transport layer involves end-to-end communication of messages. The network layer is concerned with the routing of the packets to the correct destinations. The data link layer involves the transmission of error-free data in the form of frames. And finally, the physical layer is concerned with the transmission of raw bits over the communication link.
We hope you found this video interesting and informative. Thanks for watching. Please leave a like. 1 like is equal to 1 mark for ICT exam.